On June 24th, at 6:04 in the evening local time in Venezuela, the ground moved. And then 39 seconds later, it moved again. The first earthquake measured magnitude 7.2. The second measured magnitude 7.5. Their epicenters were less than 6 miles apart. Together, they ruptured a fault approximately 175 kilometers long. That is 108 miles of fault surface, propagating eastward along Venezuela's Caribbean coast in what the USGS's own event page describes as doublet. 2 distinct earthquakes of nearly identical magnitude occurring in such close proximity in time and space that they represent a single, extraordinarily complex rupture event. French seismologists at Geoscope and the Institut de Physique du Globe de Paris went further. Their analysis suggests the entire sequence may actually be a single MWW7. 8 rupture that developed in a cascading manner with a total energy release even larger than the 2 individual readings suggest. The 7.5 magnitude main shock is the strongest earthquake to strike Venezuela since 1900, when a 7 magnitude event shook the country 126 years ago. The USGS issued a red pager alert for both events. Their own seismologist Paul Earle told NPR, "This doesn't happen very often. When they're right together, it's hard to understand what would happen." Here's what happened. As of July 4th, the confirmed death toll stood at 2,154 people killed, more than 16,592 injured, tens of thousands still missing, 58,870 structures damaged according to NASA satellite analysis. The United Nations Development Program estimated direct damage at approximately $7 billion US, roughly 6% of Venezuela's entire annual GDP, wiped out in 39 seconds. And the aftershocks have not stopped. More than 600 aftershocks have been recorded. A June 26th aftershock collapsed a bridge connecting Carabaleta to the rest of La Guaira state, physically severing a critical relief route. Active seismicity across the Caribbean continues. A magnitude 3.7 earthquake near St. John in the U.S. Virgin Islands was recorded early this morning, July 8th, at only 5 kilometers depth, a shallow event in a seismically active zone that connects directly to the same plate boundary system that ruptured on June 24th. This is not over. The question is not whether more earthquakes are coming in the Caribbean. The question is where, how large, and why this region keeps shaking. Let's go. Before I explain the ongoing seismic situation, I want to make sure you have the complete documented picture of what the June 24th earthquake doublet actually did to Venezuela, because I believe the scale of this disaster is not fully understood outside of the immediate news cycle. The twin earthquakes struck northwestern Venezuela on June 24, 2026, roughly 100 miles west of Caracas. The events occurred only 39 seconds apart, with moment magnitudes of 7.2 and 7.5 at epicenters within about 2 miles of one another. The depth of the 7.2 foreshock was 12, 6 miles underground. The 7.5 main shock was shallower, at only 2 miles depths. The shallower depth of the main shock is critically important. Shallow earthquakes, those occurring at less than 20 to 30 kilometers depth, cause dramatically more surface shaking than deeper earthquakes of equivalent magnitude, because the seismic energy has less distance to travel and less rock to dissipate through before it reaches the surface. The 7.5 main shock, at only 10 kilometers depth, delivered maximum surface shaking intensity directly to the communities above it. The USGS's finite fault rupture model describes the main shock as rupturing a fault approximately 175 kilometers long by 20 kilometers wide, propagating unilaterally to the east from its onshore epicenter along the Venezuela coast. This means the rupture started at the epicenter and raced eastward along the fault, delivering sequential waves of violent shaking to communities spread across a 108-mile corridor. In Caracas, 100 miles to the east, journalist Maria Graterol described 60 seconds of prolonged shaking, an extraordinary duration for an earthquake at that distance, consistent with a long, unilateral fault rupture propagating toward the city. You could see how the walls were moving and everything was moving around. People were screaming, she told NPR. Another journalist, Julio Blanca, described the aftermath. The capital, which is usually quite noisy, today is a scene of desolation and introspection. By July 1st, 1 week after the event, the confirmed death toll had reached approximately 2,295, with more than 11,200 injured, according to the National Assembly president. By July 4th, the EFE news agency reported the toll had risen to 2,154 dead and 16,592 injured. The USGS pager system, which uses population density, building vulnerability, and shaking intensity to model casualty probabilities, estimated a 44% likelihood that the final death toll would exceed 10,000. NASA satellite analysis identified approximately 58,170 structures damaged across the affected region. The UNDP estimated direct economic damage at US $6. $7 billion, approximately 6% of Venezuela's GDP. Verisk, the risk analytics firm, estimated total economic losses exceeding $10 billion. The humanitarian scale, the International Organization for Migration, estimated that up to 8 million people may need relief assistance. UNICEF reported 680,000 children affected. More than 28,000 Venezuelans have homes in danger of collapse. International rescue teams from Fairfax County, Virginia, and Los Angeles County. California deployed alongside teams from Mexico, Colombia, and dozens of other nations. The U.S. pledged $150 million in aid, deploying the USS Fort Lauderdale, USS Billings, C-17 Globemaster, and C-130 Hercules aircraft to support rescue and relief operations. A June 26th aftershock collapsed a bridge connecting Carabalada to the rest of La Guaira state, physically severing a relief route and hampering aid delivery to one of the most severely affected coastal areas. By early July, international rescue teams were beginning to transition from active search and rescue to recovery operations and structural assessment, the grim acknowledgement that the window for finding survivors alive was closing. This is the scale of what happened, and the seismicity has not stopped. Let me explain the doublet mechanism specifically, because it is at the heart of why this event was so destructive and why the ongoing seismicity in the region should be understood in a specific context. A doublet earthquake, sometimes called an earthquake doublet, is a seismic event in which two earthquakes of nearly identical magnitude occur in close proximity in both time and space. They exhibit nearly identical seismic waveforms in hypocenter locations, meaning they look and feel like echoes of each other, originating from essentially the same point in the Earth's crust, occurring within seconds of each other. Seismologists note that doublets are relatively uncommon in the earthquake record. The explanation for what happened on June 24th is that the first earthquake, the M7's, likely activated the second. The two events occurred within miles of one another on separate faults nestled within the Boconó fault system. The rattling caused by the rupture along the first fault increased the stress along the second, which was located closer to the surface, until the rocks gave way. USGS sea seismologist Paul Earle described the unusual nature of the event directly. This doesn't happen very often. When they're right together, it's hard to understand what would happen. The challenge is not just in understanding the mechanics, it's in how emergency response systems process two simultaneous M7+ earthquakes. Warning systems, damage assessment algorithms, and response planning are generally designed around single events. A doublet overwhelms those frameworks in ways that compound the damage and delay the response. French seismologists at Geoscope and the Institut de Physique du Globe de Paris offered a third interpretation, that the entire June 24th sequence may be better described as a single, highly complex rupture event with a moment magnitude of mid-W7, 8, larger than either individual reading. In this model, what the USGS logged as two separate earthquakes was actually one extended cascading rupture process that began on the Boconó fault system and propagated eastward along the San Sebastian fault. If this interpretation is correct, the June 24th event would represent one of the most energetically complex shallow earthquakes on the Caribbean plate boundary in the modern observation era. The distinction matters not just scientifically, but practically. A MW7, 8 single rupture has a fundamentally different stress transfer signature than two M7, 2 or 7, 5 events. It releases energy differently along the fault system and changes the calculation of which adjacent fault segments are now under increased loading stress. To understand the ongoing seismicity, you need to understand the tectonic system that is producing it. And the Caribbean plate boundary is one of the most seismically complex in the Western Hemisphere. Northern Venezuela lies within a broad, transpressional boundary zone between the Caribbean plate and the South American plate. The two plates are not meeting head-on. They are sliding past each other in a right lateral strike-slip motion, with the Caribbean plate moving eastward relative to the South American plate, at approximately 10 millimeters per year. The principal active structures accommodating this motion are the Boconó fault system and the San Sebastian fault system, which together extend more than 3,800 kilometers from the Venezuelan Andes to Trinidad. The Boconó fault is a particularly important fault in this system. It last ruptured in 1812, in the earthquake that destroyed Caracas. Since that rupture, 214 years ago, the fault has been accumulating a slip deficit. The USGS notes that this accumulated stress deficit could be released as a magnitude 7, 0 to 7, 6 earthquake. This is the crucial point I want you to hold on to. The Boconó fault last ruptured in 1812. The June 24th earthquakes ruptured primarily along the San Sebastian fault system to the east. The Boconó fault, the one that destroyed Caracas in 1812 and has been accumulating stress for 214 years, was adjacent to, but not fully ruptured in the June 24th event. The USGS locates the main shock's rupture as having started within either the eastern Boconó fault system or the western San Sebastian fault system, then propagating offshore eastward along the San Sebastian fault. This means the western portions of the Boconó fault, the segments that have been accumulating stress since 1812, may have experienced stress changes from the June 24th event without releasing their own accumulated energy. Stress transfer is one of the most important concepts in earthquake science and one of the least understood by the general public. When a major fault ruptures, it does not simply release stress from one place and return the surrounding system to equilibrium. It redistributes stress. Some adjacent fault segments experience a reduction in stress. They are brought further from failure. But other adjacent segments experience an increase in stress. They are brought closer to failure. Whether the June 24th rupture increased or decreased the probability of future large earthquakes on the unruptured Boconó fault segments is a question that seismologists are actively analyzing, and one that does not yet have a definitive public answer. What we can say is this: the Boconó fault has not ruptured since 1812. It has been accumulating stress. It is adjacent to the June 24th rupture zone. In the Caribbean, South American plate boundary continues to move at approximately 10 millimeters per year, continuously loading these fault systems with energy that must eventually be released. As of early July, more than 600 aftershocks had been recorded following the June 24th doublet. The largest aftershocks reached magnitudes of 4, 4, and 4, 5, striking east of Caracas. A particularly damaging aftershock on June 26th collapsed a bridge connecting Carabaleta to the rest of La Guaira state. USGS seismologist Paul Earle, speaking in the immediate aftermath of the June 24th events, stated there was a 40% probability of a M6 or larger aftershock in the week following the main shock, and described a M5 or larger aftershock as almost certain. The aftershock sequence of a major earthquake follows a predictable mathematical pattern described by the Omori-Utsu law. Aftershock rates decay as a power law of time, meaning they are most frequent and most powerful immediately after the main shock and then gradually diminish, but gradually for a M7. 5 event means months to years, not days to weeks. Large aftershocks, events that would be considered significant earthquakes in their own right, can occur months or even years after a major main shock. For Venezuela specifically, the humanitarian implications of an ongoing aftershock sequence are severe. More than 170 structures were identified as damaged by NASA satellite analysis. Structures damaged but not fully collapsed by the main shock and its immediate aftershocks are uniquely vulnerable to subsequent ground shaking. M5. 5. Aftershock that would cause no damage to an intact building can collapse a building that has been structurally compromised by the main shock sequence. This is why the government's instruction to citizens to remain outdoors, delivered by Interior Minister Diosdado Cabello in the immediate aftermath, was not alarmist. Cabello asked citizens to remain outdoors due to the possibility of aftershocks, and until the structural integrity of each building could be verified. The International Rescue Committee's Sierran Donnelly described the scene as cataclysmic and noted that relief workers themselves had fled their homes and were sleeping outside, afraid of aftershocks and collapsing buildings. As of today, on July 8th, the aftershock sequence continues, and it will continue for months. The broader Caribbean region has not gone quiet since June 24th. Let me give you the current picture. As of early this morning, July 8th, 2026, the Earthquake Monitoring Network is showing a M3, 7 earthquake near St. John in the U.S. Virgin Islands at 5 kilometers depth, a M4, 4 near Jiquililo, Nicaragua, and a M3, 7 near Ciudad Cortez, Costa Rica. According to Volcano Discovery's Caribbean Sea Seismicity Monitoring, the region has recorded seismic energy equivalent to approximately 6 atomic bombs in the recent period, a measure of cumulative energy release that reflects not just the June 24th doublet, but the extended aftershock sequence and regional background seismicity. The most recent recorded earthquake in the Caribbean Sea region was at M3, 4 near Leon, Nicaragua. On May 16th, 2026, 39 days before the Venezuela doublet, a M6, 0 earthquake struck 68 kilometers northeast of St. John's, Antigua and Barbuda, in the North Atlantic Ocean north of the Caribbean plate boundary. This event was the largest in the Caribbean region in the preceding 90 days. It was followed by the Venezuela doublet on June 24th and the ongoing aftershock sequence. The Virgin Islands are located on the northeastern corner of the Caribbean plate, at the zone where the Caribbean plate boundary transitions from the strike-slip system of Venezuela's coast to the subduction system of the Puerto Rico Trench, the deepest point in the Atlantic Ocean and one of the most seismically active zones in the entire Americas. A shallow M3. 7 in this zone this morning is not a catastrophic event, but it is a reminder that the Caribbean plate boundary is active along its entire length, not just in Venezuela. The Caribbean Sea averages approximately 15,000 earthquakes per year, about 41 per day. Of these, roughly 566 per year are M4 or higher, 33. 6 per year are M5 or higher, and 3. 7 per year are M6 or higher. Caribbean Sea has had at least 61 earthquakes of M7 or higher since 1900, approximately one every 1 to 5 years on average. The statistical picture is clear. The Caribbean is not an anomalously quiet region experiencing a sudden increase in seismicity. It is a persistently seismically active region that has just experienced one of its most energetic events in over a century. The ongoing activity, aftershocks in Venezuela, background seismicity across the plate boundary, is the region's normal behavior, now superimposed on an elevated baseline established by the June 24th doublet. This is the question everyone is asking, and I want to give you the most honest, scientifically grounded answer I can. The short answer is, we cannot predict earthquakes. Not in the sense of specifying a future earthquake's time, location, and magnitude in advance. Earthquake prediction in that sense does not exist as a functioning scientific tool. Anyone who tells you specifically when and where the next large earthquake in Venezuela will occur is not giving you science. They're giving you speculation. The longer answer is, the probability of future significant seismic activity in and around Venezuela is elevated compared to pre-June 24th levels, for several documented reasons. The first reason is aftershock probability. USGS's own assessment in the days after the main shock estimated a 40% chance of a M6 or larger event in the same region within 1 week. While that window is past, the Omori-Utsu aftershock decay law tells us that significant aftershocks remain possible for months. The probability diminishes with time, but it does not reach zero. The second reason is fault system stress. The Boconó Fault, which last ruptured in 1812 and has been accumulating stress for 214 years, is adjacent to the June 24th rupture zone. The stress transfer from the June 24th event onto the unruptured Boconó Fault segments is being actively analyzed by seismologists. The answer to whether the June 24th event increased or decreased the Boconó Fault's proximity to failure is not yet publicly established, and until it is, the elevated concern about the broader fault system is scientifically reasonable. The third reason is historical pattern. The region experienced a doublet of M6, 2, and M6. 3 in September 2025, 9 months before the June 24th event, in the same general zone. This sequence demonstrated that the fault system was moving toward larger rupture. The June 24th doublet may itself be part of a longer temporal progression of stress release along the Boconó-San Sebastian fault system, not an endpoint of that progression. What does this mean practically? It means the people of Venezuela and the humanitarian responders working there should continue to treat any damaged building as structurally suspect. It means that public guidance to avoid damaged structures remains appropriate. It means that structural engineers conducting building assessments in the affected area should do so with the understanding that additional ground-shaking events remain possible. For people elsewhere in the Caribbean region, in Puerto Rico, Jamaica, Trinidad, the Lesser Antilles, Hispaniola, the Venezuela earthquake should serve as a reminder that this region sits on one of the most seismically active plate boundaries in the Western Hemisphere. The January 12, 2010, Haiti earthquake, which killed more than 100,000 people, occurred on the Enriquillo Plantain Garden Fault, a different segment of the same Caribbean North American plate boundary. The February 8, 2025, M7, 6 Caribbean Sea earthquake near Honduras occurred on yet another segment. These are not isolated events. They are expressions of a continuously active tectonic system that will continue to generate significant earthquakes on timescales that span decades. The immediate search and rescue phase of the Venezuela earthquake response has ended. International teams have transitioned from looking for survivors to conducting recovery operations and structural assessments. But the humanitarian crisis is not over. It is entering a longer, quieter, and in some ways more difficult phase. Up to 8 million people may need relief assistance, according to the IOM. More than 28,000 Venezuelans have homes in danger of collapse. 680,000 children have been affected. The Venezuelan Education Action Program on Human Rights flagged inconsistencies in the government's death toll reporting and called for independent verification. At one point, an official update reported only 20 additional deaths over a 24-hour period that followed significant aftershock activity, raising questions about data collection and transparency. The ongoing aftershock sequence compounds the humanitarian challenge. People who cannot return to damaged homes must shelter in temporary accommodations, which in Venezuela's already stressed humanitarian environment means displacement, exposure, and increased disease risk. The IRC's team on the ground is working on sanitation systems and disease prevention. Cholera, typhoid, and other waterborne diseases are significant post-earthquake risks in densely populated areas with damaged infrastructure. The political dimension adds additional complexity. The U.S. has deployed significant military and humanitarian resources to Venezuela, USS Fort Lauderdale, USS Billings, C-17 and C-130 aircraft, elite urban search and rescue, teams from Fairfax County, VA, and LA County, CA, in the context of a complex and strained diplomatic relationship with the Venezuelan government. The earthquake response has become, simultaneously, a humanitarian operation and a geopolitical moment. If you want to help, the most effective channels are established international humanitarian organizations with verified on-the-ground presence: the International Rescue Committee, the Venezuelan Red Cross, UNICEF, and UN agencies with verified access. Verify before you donate. The Venezuela earthquake has generated a significant influx of fraudulent relief solicitations. Let me close with the specific things I am tracking in the days and weeks ahead on this story. The first is the aftershock sequence. I'll be watching the USGS event page for the June 24th earthquake for any M5, 5 or larger aftershocks. Events of that size are capable of causing additional structural collapses in already damaged buildings and represent ongoing safety concerns for people in the affected region. The second is the Boconó fault analysis. As seismologists publish their stress transfer analyses, which typically take weeks to months to complete and peer review, the scientific community will be able to give a more specific answer to the question of whether the June 24th event increased or decreased the risk on adjacent fault segments. I will update you when those analyses are published. The third is regional Caribbean seismicity. The Caribbean plate boundary is active along its entire length. I am monitoring USGS and regional networks for any significant events along the Puerto Rico Trench, the Muertos Trough, the Enriquillo Plantain Garden Fault in Hispaniola, and the Lesser Antilles subduction zone, NEM5. 5 or larger in these zones will get its own update. And the fourth is the humanitarian situation in Venezuela. The death toll is still rising as search teams reach more remote areas. The final confirmed count is likely months away from being established. I will update this number as official sources publish it. Subscribe and turn on notifications for those updates. Stay safe. And for anyone in the Caribbean region, know your local earthquake preparedness plan. Know where the structurally sound buildings in your community are. Have a go bag ready. The Caribbean plate boundary is not finished moving.